So welcome back, Level 2 physicists, continuing on with the Level 2 electrical systems external, and today looking at Ohm's law and resistance. So going back to mechanics, our first external, what is potential energy? Well, potential energy is stored energy. So what has that got to do with electricity? Well, it relates to voltage. Okay, so voltage is the potential energy difference between 2 points in a circuit. Okay, so voltage equals the potential energy difference, or PD. Okay, and the symbol is volts, and also the units is volts as well, or capital V. Okay, and volts are essentially the joules of energy divided by the coulombs. Okay, so it's energy divided by charge, E divided by Q. And which battery has more voltage? It will be the 9-volt battery, because it has 9 volts of energy, so 9 joules per coulomb. Okay, so the other concept we need to touch on is resistance. Okay, so resistance is the difficulty of how electrons flow. Its symbol is capital R, and its units are quite funky. They are the ohm. Okay, and it's kind of a horseshoe. And which one has more resistance for water to flow? It is, of course, the hose, because the hose has less cross-sectional area, so it requires a lot more energy to allow that water to flow at the same rate than a giant pipeline. So conductors and insulators. So conductors, like the key, have low resistance, so electricity flows quite quickly through them, and insulators, like the rubber ducky, have high resistance. It requires a lot more force to push electrons through an insulator. So remembering our Kung Fu circuits, so resistance in a circuit, there are a number of different components that act as resistors when placed in a circuit, and you can see them there. There's the resistor, the variable resistor, the lamps, the potentiometer, also the light-dependent resistor, and the thermistor, okay, which you have to be familiar with. Okay, so in summary, in terms of electrical properties, voltage is the potential difference. Its symbol is capital V, and also its unit's capital V, which stands for volts. Current is the rate at which the charges move through a wire. Its symbol is capital I. Its units are the ampere, or amps for short, and its symbol is capital A, or the unit. And the resistance is how hard is the current to flow through a conductor. Its symbol is capital R, and its unit is the ohms, that weird horseshoe shape. So how are they related? Well, as voltage goes up, current goes up as well. So voltage is proportional to current, and as resistance goes up, the current goes down. Okay, so that means that resistance is proportional to 1 over the current. So this is where Ohm's law comes in. Okay, so Ohm's law is essentially the relationship mathematically between the electrical properties, and the relationship is that V, voltage, equals current times resistance. Okay, and that means also the current is voltage divided by resistance, and resistance is voltage divided by current. Okay, you've got to memorize that. It becomes quite important. So if you have a linear relationship between current and voltage, it means the component is ohmic. It obeys Ohm's law, and resistance therefore is a constant, which is the gradient. We also have non-ohmic conductors, okay, which means that the relationship between voltage and current is not linear. So many components, like a filament lamp, or diodes, for example, or semiconductors or thermistors, do not show a ohmic relationship. For example, the resistance of the filament in a filament lamp increases as the filament heats up. They're non-ohmic. So looking at resistors, you can combine resistors in 2 ways, either series, which is the ones on the left, or in parallel, which are the ones on the right. Okay, so when combining resistors in series, essentially the total resistance of that circuit are the sum of the resistors. Okay, so R1 plus R2 plus Rn, where n is any number. And when you're combining resistors in parallel, it's important to note that 1 over the total resistance equals 1 over R1, 1 over R2, 1 over R3. So in series, the resistance increases as you add more resistors, whereas in parallel, the resistance of the total resistance decreases as you add more resistors in parallel. Okay, so that's basically a summary of resistance and voltage.